Welcome back, dear students, with geometry for the second preparatory. Today we're going to talk about the equality of the area of two parallelograms. First of all, we have to remember the properties of parallelogram. First of all, what the meaning of parallelogram? It is a quadrilateral in which each two opposite sides are parallel to each other, as AB is parallel to DC and AD is parallel to BC. So we have also to know the properties of parallelogram, which are each two opposite sides are equal in length, as the length of AB equal to the length of DC. Also the length of AD is equal to the length of BC. Also the measure of each two opposite angle are equal in measure, so measure angle A is equal to measure angle C and measure angle B is equal to measure angle D. Also the sum of two consecutive angles equal to 180, as measure angle A plus measure angle B is equal to 180 degrees. For example, if measure angle A is equal to 120 degrees, then the measure of measure angle B is equal to 180 minus 120, which is equal to 60 degrees. Also we have the diagonal AC and the diagonal PD bisect each other at the point, say, M. What the meaning of bisecting each other? The length of AM is equal to the length of MC. The length of DM is equal to the length of MB. Okay, today we have theorem 1. It's talking about if we have two parallelograms and they having a common base, which is BC, and this base is parallel to another straight line AF, then these two parallelograms are equal in area. So here we have two conditions and one result. The condition number 1, they must having the common base, which is BC. Condition 2, this base BC is parallel to the other base AF. Then the area of ABCD is equal to the area of parallelogram CBEF. Okay, we have to know the area of parallelogram. The rule of this area is equal to base times height. How we can determine the base and the height? Okay, in the figure parallelogram ABCD, if we have the base DC, if this base is base 1, then the height is the line which is perpendicular from the opposite vertex A perpendicular to the opposite base, say at X. It's height 1. So the area of parallelogram ABCD is equal to base 1, which is DC, times height 1, which is AX. Also we have another base, which is BC. Okay, BC, the second base. So the perpendicular, or its altitude or its height, is also from A to this base perpendicular, say at point Y. So the area of this parallelogram, we can say that base 2 times height 2 times height 2, which is BC times AY. Okay, what about corollary 2? We have here corollary 2. It's talking about if we have rectangle ABCD and the parallelogram having the same common base AB and between two parallel straight lines, then they are also equal in area. Okay, we have here an exercise complete. Number 1, the area of parallelogram whose base length is equal to 7 and its corresponding height is 4 centimeter. So base 1 is equal to 7 centimeter and height 1 is 4 centimeter. So the area of this parallelogram is base times height, which is equal 4 times 7, which is equal to 28 centimeters square. Exercise number 2. If the area of the parallelogram is 50 centimeters square whose base length is equal to 10, then the length of the base. Okay, to get the base, we can draw here a triangle like that. Okay, area equal base times height. So here we have we want to get the base. By hiding the base, we can get it by making a division between the area of the parallelogram and the height. So the length of the base is equal to area over height. So 50 over 10 is equal to 5 centimeter. Okay, exercise 2. In the opposite figure, he says that ABCD is a parallelogram. ABCD is a parallelogram, and DCEF is also a parallelogram. He wants to find that the area of the figure MFEC is equal to the area of the figure ABMD, the blue part and the green part. How I can get that? By looking to this figure, we can find that these two parallelograms are having the same base or a common base, which is DC, and between two parallel straight lines. So the area of parallelogram DFEC, area of DFEC equal to the area of CBAD. Okay, these two parallelograms are equal in area. By get rid the area, or by subtracting the area of this yellow triangle DCM, by cancelling this part or this area of this triangle, we get the remained part here, and the remained part here will be equal in area. So the area of the figure DECM is equal to the area of APMD. Okay, exercise number 3. In the opposite figure, we have rectangle. XYED is rectangle. Okay, and APED is a parallelogram. He's asking about the area of parallelogram APED. How I can get the area of this parallelogram? Although I haven't any okay, I have the length of the bases, but I haven't the length of the height. Okay, we can see that this rectangle, and the parallelogram are having the same common base, which is ED, and between two parallel straight lines. We have to know that the rectangle is one of the special cases of the parallelograms. So we can deal with the rectangle as a parallelogram. So the rectangle and the parallelogram are equal in area, because they have the same base, which is ED, and between two parallel straight lines. If they are equal in area, I can get in easy way the area of rectangle, which is 12 times 24. 12 times 24. So the area of rectangle XYED is equal to 24 times 12, which is equal to 288 centimeter square. So the area of this parallelogram is equal to 288 centimeter square. The second required is he was asking about if the length of AD is 30. Okay, the base, this 30 centimeter is the length of one of the two bases of the parallelogram. Find the perpendicular to AD. Okay, it's not from, it's to AD. How I can get the perpendicular? I have the base and I have the area. So to get the length of the height, it will be area over the length of the base. So it's 288 over 30. The result will be 9.6 centimeter Thank you and wait for us for the next video.